Hello. So we're going to try a problem that involves resistors in parallel. Okay. Now, once again, the diagram is already given to us with the corresponding voltage supplied by the battery, the potential difference supplied by the battery to actually get the circuit going. And you can see here, the current that comes from the battery is split three different ways. And take a look at the values of the resistors. They're not split unequally, as a matter of fact, depending on what the value of the resistor is. Okay, we have four things we're looking for, and so I will go ahead and dub this diagram as something that we're given. Okay, so take note the differences between resistors in series and resistors in parallel, which we have here. So I'm going to go straight to what are we looking for. Okay, find the current in each resistor. So that's pretty much find out what is I1, I2, and I3, and also find what is the total power. So we're total power, which is simply the sum of all the other individual powers used up by each resistor. And so find power used up by resistor 1, that by resistor 2, that by resistor 3. And then find the equivalent resistance of the circuit, which is not as straightforward as that it is for series. And then find once again here, the total power from the equivalent resistance. So whatever we get for part D should actually be the same as that in part B. So two different ways. So this looks to be a very interesting problem. And let's see what formulas we have. Okay, we're going to use good old Ohm's law. And we're also going to need a formula for power. Now take note, there are three formulas for power used by a resistor. We only need the middle one. So I'm going to erase the other two. Okay? And we're also going to need the formula for resistors in parallel, and the equivalent resistance is actually the reciprocal of the sum of the reciprocals. Okay, try saying that 10 times fast. In this case, there's three resistors, and so just 1 over R1 plus 1 over R2 plus 1 over R3, and that's pretty much it. We're going to use this equation twice. Okay, so let's get to it. Now I already have the calculations done for me, so you can follow along and do the pause and calculate for these individually. Remember that Ohm's law is V equals IR, and if I solve for I, what I'm supposed to solve for in A, I get that I equals delta V over R. Now the thing about resistors in parallel, they actually have all the same potential. Okay, it's the current that is split up. So I'm going to go ahead and write that as well. The potential from the battery, that is delta V1, is the same all throughout. It's actually even intuitive not just to write any numbers. It doesn't need any numbers at all. It is the current that is split up. It's the sum of its parts. So the current flowing through resistor 1 is the plus the current going to resistor 2, and that of resistor 3 should equal the total current. Okay, so be sure to take a look at your notes. Okay, so I'm just going to go ahead and pull in the numbers here. For I1, it's all going to be the same, 18 volts and 0 ohms. I2, still 18 volts, but now twice as much. And so just imagine what's going to happen to the current as I'm going to write down the answers in just a little bit, and 3 times as much resistance. So for 3 times as much resistance, you expect the current to be bigger or smaller. I'm going to expect it to be smaller here and bigger here by 2/3 exactly. Okay, and sure enough, the current here, let's put that in red, is in amperes. Okay, so it's kind of important to take a look back and see if your numbers follow the rules set by the laws, like Ohm's law. Okay, so that is A is down, and P, I'm going to just take these values and use the formula for power that I have. Okay, now that I know the current, so I'll solve for P1. It kind of lends itself naturally as I just write this right across there. It's going to be 6.0, and then once again the 3 ohms, and just using the answers that I had previously. Okay, so now you can also ask the question, which one would have more power used? Which one resistor would use more power, the potential energy supplied by the battery? Well, this one's actually pretty straightforward. We're expecting it to be the one that used the most current, and sure enough, it is resistor 1, which uses about, well, exactly 110 watts. And the less current that flows through it, the less power. But we're also asked to find the total power, and that results in something that's about 200. It's because we have, oh, it's exactly 200. Okay, but the answer that they had, they put it in scientific notation to be along the same lines as 2 significant figures, as all the given were. Okay, so watch out for the significant figures. And I think I may have some room to start solving for the equivalent resistance. Now I'm going to do this a little bit different. Take note the ohms are on the bottom. It's R2 and R3. Now if you add all of these together using LCD, or you can actually just turn this to 0.33, and this is 0.17, and 1 divided by 9 is 0.11. You'll actually get 11 over 18. Ohms is still on the bottom, or you're going to get 0.61 bar. But take note the units is 1 over ohms. I actually prefer doing it this way, solving using the LCD, which is actually 18. Because that means that our equivalent is the reciprocal of that. So our equivalent is 18 divided by 11 ohms, which is exactly equal to 1.6 ohms for two significant figures. Okay, so let's see if this answer here is equivalent to what the power that we'll get by solving here. And I might just have enough room right here. So power, total power. And I have to use a different formula, actually. The delta V over R, because we're given that from the battery, and this is the R equivalent. Okay, so I should have added that here. So not using that twice after all. And that's 18 volts squared divided by the 1.6 ohms. Now take note, when you're adding resistors in parallel, they're actually going to end up with the resistances that are way less than adding them together straightforward. So take note that 1.6 is definitely way less than 3, much less than 6, much less than 9. Okay, and sure enough, 8 square of 18 divided by 1.6 gives us exactly 200. Close enough. Whoops. Had some rounding error in there. And the units for power, by the way, are in watts, or joules per second. Okay. Now take note, I used a different formula for power in part D than I did for part B. Okay, I went through that a little bit fast, but once again, you can pause or go back and to try to solve this problem yourself based on this given. Okay, hope you all enjoyed that. Ciao.